Hi everyone, my name is Gilad and this is Nathan. And we're here to talk about crypto mining and how it is the new force behind remote code execution attacks. Now, I didn't bring any candy, but I will be happy if you ask questions anyway. Let me introduce ourselves first. So, as I said, my name is Gilad Yehudai. I work at Imperva, which was mentioned before. I'm a security researcher at Imperva for the past 2 years. And I have a bachelor and master degree in mathematics. And with me is Nathan, who's also a security researcher from Imperva. And he has a master and a bachelor and master degree in computer science. And he works in cybersecurity. His thesis was in cybersecurity. Okay, let's begin. Before I start the talk, I want to say a few words about the evolution of web attacks and, well, the economical aspects of the evolution of web attacks across time. If we look at the more classical attacks, for example, data theft or SQL injection, then the attacker had to steal data from someone. He did an SQL injection, stole some data, and he had to sell it to some kind of third party in order to gain money. If we look at network theft, for example, enlisting a computer to a DDoS botnet, then the attacker also had to attack someone, enlist it into his botnet, and then sell this botnet service to some kind of third party. A newer kind of attack, which is, for example, data corruption or a more particular ransomware, the attacker tried to corrupt someone's data, encrypt the data of someone, and then he had to sell his service to the person he's attacking, right? He's getting money from the person he's attacking, so there's no third party involved, but he still have to contact somebody in order to gain money. But when we talk about crypto mining, that's like the golden globe for attackers. It doesn't need to contact anybody. In this kind of attack, CPU theft, what it do is that it just steals the computation power of the person is attacking, and all he do is he mine cryptocurrency and he gains money through it. He doesn't need to sell his service to the person he's attacking or to any kind of third party. That's why crypto mining, that's one of the reasons crypto mining is becoming so popular today, and we'll see it in a couple of slides. What are we going to talk about today? First, I'm going to say a couple of words about remote code execution vulnerabilities, how they work. I'm going to mention some of the payloads and some of the trends that we see that are related to remote code execution vulnerabilities. After that, Nathan will deep dive into the crypto mining malware, some of the malwares we saw. We'll see some of the code that the malwares are running. And we also follow the money trail, and we'll see some of the wallets of attackers that we actually caught in our data. After that, I'll say a couple of words about mitigation methods, how to prevent attackers from infecting our machines with crypto mining malwares, and a couple of key takeaways. Let's start with remote code execution vulnerabilities, or RCE. So, remote code execution is a generic name for a software bug that allows an attacker to execute any command of the attacker's choice on a target machine through the internet. That's the definition of remote code execution vulnerabilities, and usually this kind of vulnerabilities happens when a couple of conditions are met, and these conditions includes that the machine or the system gets untrusted data, and there is not enough validation done by the machine. So that's some kind of insecure coding, and that's where remote code execution vulnerabilities happen. And let's see a quick example of how it works. You can enjoy my Rick and Morty joke. Here we have a vulnerable server. And what this command does is just, it pings any IP that we do. So let's ping our own IP. It just pings the IP, right? But if there is not enough validation done by the server, we can escape this code using some kind of escape character, and maybe print something that we want to know. For example, the task list of the system. And here we have the task list. So what happened there is that we did run the ping code, right? We did ping the command, but we also run another command, printing the task list of the system. Let's go back to the slides. What happened here behind the scene is that the system gets the target parameter from the IP, the target from the IP parameter of the request. And then it executes the ping command using the shell exec command on the target. And as you can see, there is completely no validation done here. I mean, whatever you write here will be executed. So if you ping execute an IP and then escape it and run another command, concatenate a command, it will just run it. And that's, for example, a remote code execution vulnerability. Now, in the past year, or maybe a little bit more, we have seen a development in remote code execution vulnerabilities called insecure deserialization. Now, this kind of vulnerability was added to OWASP top 10 list in 2017. It was number 8. And the way this vulnerability works, we saw a lot of new vulnerabilities related to this kind of insecure deserialization. Is that if we have, for example, some kind of object in our memory, let's say we have a Java object, a Java array, for example, and we want to send it via the internet somewhere. The way we do it is we have the object in our memory, we serialize the object. For example, we take the object, the Java array, and turn it into a byte stream, or for example, an XML. And after that, we transit the object via the internet, and then we send this object to somewhere, to some receiving machine, and whoever receives it does deserialization. It takes this byte stream or XML and turns it back into a Java array. And then he has this object in his memory. Okay, let's see an example of an insecure deserialization vulnerability and how it works. So yeah, so that's a good point. So when the channel is insecure, thank you for that note. Some attacker can get into the object while it's in transit, right? The orange part in the middle, and he can just manipulate the object, add some kind of code, and the machine that receives this object deserializes it and might run the arbitrary code that the attacker wanted. Thank you. So in this example, we have a class called example2, and this class has a function called Wakeup function, which is called when the unserialized method is used. And what this function does is just it evaluates some kind of parameter, and it will evaluate some PHP code. But the problem here is that the user data uses the unserialized method when there is completely no validation. It just goes to the data parameter inside the cookie and runs whatever is inside this parameter. For example, if we send this kind of request, like this simple HTTP GET request, inside the cookie you can see the example2 parameter, which is the object we want to unserialize, which is completely fine. But if we add this code at the end, this PHP info, this code will be evaluated. And we can insert the PHP info is not malicious in any way, but we can insert any kind of code there, and in this kind of class, it will just run the code. So that's some kind of insecure deserialization vulnerability. Yeah, even if it's not encrypted, this kind of vulnerabilities also happen when, let's say we have a web application that runs some kind of code and receives like a serialized object, and it deserializes it, then yeah, for example, an API will open it. So we don't, this kind of vulnerabilities doesn't, even if the network is secure using HTTPS, for example, or encrypted, it still happens, and this vulnerability is still here. In our data, we saw a sharp rise in insecure deserialization vulnerabilities over this is a graph of the last 3 months of 2017, and as you can see, there is a sharp rise in attacks related to insecure deserialization vulnerabilities. And there are also many new vulnerabilities that are released related to this kind of insecure deserialization. And another statistics that I want to show you is that this graph is relevant to around January 2018. The blue lines here represent the amount of vulnerabilities, remote code execution vulnerabilities released each year. And as you can see, over the years, there are just more and more remote code execution vulnerabilities released. And on 2018, if we look at the graph that is relevant to today, we will see that 2018 will probably surpass 2017 and by much more. And the red line at the top represents the average CVSS score of these vulnerabilities. The CVSS score is some kind of risk score between 0 to 10 that is given to every new vulnerability released. And the average CVSS score of remote code execution vulnerabilities is around 8.5. So what we get here is a lot of new vulnerabilities released over the years, and these vulnerabilities has a very high risk. And another statistic is that these vulnerabilities has about more than 50% of them as a public exploit, publicly published over the internet. And why public exploit is a problem is because every script kiddie that finds this exploit in the internet can just download it, run it, use it on whoever he wants. And what we get here are many new vulnerabilities with public exploit that everyone who just knows how to run a simple computer program can run them and attack whatever vulnerable web application he wants. Okay, the next thing I want to talk about is the payloads. What attackers are actually trying to do when they try to exploit this kind of remote code execution vulnerabilities. The first payload that we saw in our data is reconnaissance attacks. In this kind of attacks, the attackers are trying to trying many different vulnerabilities on a single or many websites and see whichever works for them. And when they see that a vulnerability that actually passes on and is successful for them, they launch the real attack. The next kind of payload is the botnet payload, where the attackers are trying to enlist vulnerable machine into their botnet, which we saw mainly DDoS botnet, but we also saw other kinds of botnet, for example, ATO, account takeover botnets, or comment spam botnets. And in this kind of attack, the attackers are trying to enlist the affected machine into their botnet and launch the attack whenever they want or on call. The next kind of payload that we saw is cryptomining malwares. In this kind of payload, the attackers are trying to infect the vulnerable machine with a malware, with a cryptomining malware, where the affected machine will just mine cryptocurrency for the attacker's choice, or using the attacker's pools, and we'll talk about it later. In our research, we focused on the botnet case and the crypto mining malwares. There are also other kind of payloads, for example, trying to affect a vulnerable machine with ransomware, and but we haven't saw much of them, so we focused on the middle two. We saw kind of a shift in the trends of the payloads in the last couple of months, where if we look at September 2017, around 50% of the attack included the crypto mining malware payload, and 50% included the DDoS botnet payload. But if we look at December 2017 in our data, almost 90% of all remote code execution attacks included the included the crypto mining malware payload. This means that attackers are going to this way. This is the new trend today. Attackers are trying to infect a vulnerable machine with crypto mining malwares. And now Nathan will deep dive into the crypto mining malwares themselves that we actually saw in our data. So, yeah.
בדיוק שתחזור? לא. רגע, זה בסדר עליי? וזה? Okay, so hello. I'm gonna talk about crypto mining malwares and how they work. We will focus on an attack we saw in our data. So the infection chain of this attack consists of 3 popular stages. At the beginning, some vulnerability is exploited in order to download the entry script. In our case, a remote code execution vulnerability is used. This script will download the malware with other needed configurations, and then we'll try to run it, which result in infection of the system. So let's take a look at the attack, how the attack begins. This is an XML object. This object will be handled by the server, and the attacker here tries to exploit an insecure deserialization attack. It does it in order to download and execute an image file, which is the entry script. So the script we can see here some basic evasion techniques. The script runs with -q arguments, meaning a quiet mode, and the extension is JPG, which is an image file. And we will clearly see that this is not a real image file. Now we will dive in and talk about the main characteristics of this attack. So, such as killing other competing processes and gain persistency on the server, and how we download it. So, this is the image file that had been downloaded previously. You can see this is a real image file. We can see from the header that this is a shell script and not an image file. The attacker here, I don't know if you can see from there, the attacker here tries to kill other mining tools. Very egoistic one. For example, the MinerGate. MinerGate is a very popular mining tool that used a mining pool. Later, the script tries to kill the security controls of the system. For example, the Carbon Black and other one in the script. By doing that, the attacker avoiding detection of the later on crypto mining malware and optimizes performance by doing those actions. In the next stage, the malware, the script, tries to gain persistency on the server by using a cron job, which is a scheduled task in Linux systems. Any custom task can be scheduled using the cron service. Okay? Until now? We can see here that a dynamic configuration is downloaded by the script, and we will soon examine this dynamic configuration. And this is the actual download of the malware. The script downloads the GCC file, which is the compiler, but this is not the real GCC compiler. This is the real mining tool. This is the Cryptominer. And then the entry script calculates the number of cores to optimize the performance of the Cryptominer. Okay, so the last line is the running of the Cryptominer itself, with the command no hap in the beginning. So now we'll review the configuration file that had been downloaded previously. We can see from this JSON file that the mining algorithm is Cryptonite. This is a widely used algorithm that used to mine cryptocurrencies like Monero. This is a proof-of-work algorithm, if you're familiar with the crypto mining idea. Okay. Another thing we can see here that the crypto miner can use up to 90% of the CPU, which leaves 10% of the CPU to the server, which, of course, that you know, may cause a denial of service to this application. I don't think they tried to hide themselves. I think they wanted to do it to earn a lot of money in the beginning, and that's it. I don't know. This is what we saw in the attack. So, okay. And in the attack we are looking at, we can see that the attacker uses a mining pool. So what is it, a mining pool? Mining pool is a group of miners that agree to share their performance, to share their resources between each other, and to split the reward of the money after the mining. So there are many types of mining pools which can handle many kinds of cryptocurrencies. This one especially is designed to mine Monero. We can see here the URL is minexmr, which is Monero, if you're familiar with the cryptocurrencies. And inside this dynamic configuration file, we can see that the URL and the user is needed in order to transfer the money to the right place, which here the user is the attacker itself. This is the wallet ID of the attacker. Yeah. No, because Monero is anonymous currency. This is the idea of Monero. Sorry? No, you don't. No, it's just a wallet. No, it's not work like that. Yeah, just a public key. This is public key of the crypto miner. So, another? Yeah, sorry. Because the script is designed to start up the first crypto miner, and the executable that you saw, the GCC, is the crypto miner tool. Is a totally legal tool that's used by the malware. This is a totally different idea. Okay. Sorry. Okay. Okay, so we've just covered the basic crypto mining malware, and now we can talk about the next evolution of the crypto mining malware. The Redis WannaMine. We gave it the name Redis WannaMine. This malware is more advanced than the previous one. It has all the basic properties of the previous malware and a couple of more advanced ones. The difference expressed in how the malware spreads out, which acts like a worm. The malware tries to replicate itself by scanning the network for other vulnerable systems and then try to infect them using the entry script again, just to replicate itself like that. So, but in order to talk about the new malware properties, we need to review some key components. Are you familiar with this screen? I hope you. I hope you do. This Windows was part of the most famous ransomware attack in the last years. The attack, named WannaCry, affected more than 200,000 computers around the world. This is the most familiar ransomware attack. So why was this attack so successful? Yeah, okay. Yeah, that's true. But there is another reason to that. It was there is an exploit that developed secretly by the NSA that called Eternal Blue. This is the first key component for how this malware that we talk about propagate itself. So this exploit developed secretly by the NSA and exploits a vulnerability in the SMB protocol of Microsoft. It developed secretly, and it wasn't enough time to all of the world to patch it, so it took time. Now we will talk about the second component. This is Redis. What is Redis? So Redis is an open source in-memory database, and it's designed for applications that needs a low response time. Redis first released 8 years ago and become very popular since then. But another thing, Redis designed to run inside trusted network and inside trusted environment. So there is no authentication by default to Redis. So let's go back to the malware and focus on the propagation process. We come back to the malware and we talk about the key components now. To scan the network quickly, the malware uses the external lib masscan. This is a very cool lib that can scan the whole internet in 10 minutes, like Nmap, if you're familiar with Linux systems. No? Okay. The malware downloads, compiles, and installs this tool. And after the installation, the malware scans for IPs with an exposed Redis port. And then tries to infect them using the same entry script that we saw earlier. So this look like this. The same process happens with the SMB protocol. The script scans for IPs with an exposed SMB port and then uses the Eternal Blue exploit to propagate inside the network. So we can see how the attacker utilizes the internal network, the trusted network resources, to his own mining tool. By only hacking the web application, he could get access to the trusted network. Okay, so let's summarize the steps of the malware. At the beginning, some vulnerability is used in order to create the first attack, the first instance of the malware, the entry script, and then infect the computer. But until now, it was similar to the previous one. But now, the new one scans for a Redis exposed server and tries to propagate through those instances on the network. And in the next, the malware scans for exposed SMB ports and propagates through the Eternal Blue exploit. Okay, great. So let's talk about money. Okay, as mentioned before, mining pool is an idea of sharing resources between miners, and we are now looking at mining pool that belongs to Monero mining pool, MineXMR that we saw earlier. This attacker earned around 41 Monero, which is $10,000. This is only from our data. Maybe you have a lot more wallets in there. We don't know if this is all the money he got. This is what we saw. Single wallet that we saw. Maybe this attacker do a lot of things. I don't know. Yeah? I don't know exactly how many there are. This is a mining pool. You can see because it's Monero. You only can see how money got inside the pool. You don't know what the attacker did with the money. This is the idea of this currency. It's totally anonymically. Of this wallet that belongs to this attacker. Single attacker earns this. This is what we know. We also saw other cryptocurrencies mining our data. Also, most of the attackers tried to mine Monero. Yeah. No. How? Okay. But we don't know. We don't connect it to the whole internet. We can see all of this attack. I don't think we can know all this information. Okay, sorry. So we also saw other cryptocurrencies in our data. Although most of the attackers try to mine Monero. The first one is Carbowanek, which is Ukrainian-based cryptocurrency. I don't know if you're familiar with this cryptocurrency. The attacker earned only $400, not so much. And the second is pretty new cryptocurrency called Electronom, and the attacker earned more than $15,000. So this is a lot for only one attack. Uh, we didn't check every day. This is the only way to know. We needed to check every day to do that, but we didn't do that.
If you don't like have security, go to mining.
Yeah, the money in mining. Yeah. So Gilad will continue me now. We'll go back to Gilad.
Okay, I'll answer that. As we saw before, exactly. Uh, so as Nathan showed before, there was an XML. There was a snippet of code with an XML. That's the insecure deserialization vulnerability that the attackers used in order to run a wget command to download some kind of external shellcode. He ran the shellcode, and from the shellcode, he downloaded the malware. There are a couple of steps, but it all begins with the remote code execution vulnerability. They're all exposed. Yeah, so yeah, there are many vulnerabilities related to Drupal. There was a Drupal Geddon, if you know about it, in the last couple of weeks, and there are also vulnerabilities related to Apache Struts, for example. So there are many insecure deserialization vulnerabilities in many different systems. Okay, so one question that you haven't asked me is that we saw a couple of cryptocurrencies, right? But why not Bitcoin? Was that the question? Okay, I'll try to answer it. I'll give you a couple of reasons. We saw three cryptocurrencies. There are actually a couple of more that are being mined, but we haven't saw a single attacker trying to mine Bitcoin. We have a couple of reasons for it, and I'll try to convince you about them. So first, usually in order to mine Bitcoin, you need specific hardware, usually very strong hardware. For example, you need GPU, graphic processor, or an ASIC. And when attackers are trying to infect vulnerable machines with their malware, they don't know which kind of hardware these machines are running. So they need to rely on regular CPU, on the regular computation power that these machines have. And cryptocurrencies like Monero or Electronom are running using the Cryptonite algorithm. This is the proof of work algorithm Nathan mentioned before, and this algorithm can be used to mine cryptocurrencies using regular CPU. That's the first reason. The second reason is about anonymity. And when we talk about cryptocurrencies, there are a couple of levels of anonymity. Bitcoin is anonymous, but it has kind of a low level of anonymity. And that is because when a transaction happens, someone gives someone else Bitcoin, then it is possible to trace who was the sender, who was the receiver of this transaction, and also how much coins were transacted. but it's kind of anonymous because we are not able to see who are the real persons who are in this transaction, but we can see their wallets. When we talk about cryptocurrencies like Monero or Electrum, they have a higher level of anonymity. Because in these cryptocurrencies, when a transaction happens, it is not possible to trace who was the sender, who was the receiver, as well as the amount of cryptocurrency that was transferred. And this is what makes it so attractive for hackers who just want to hide their traces when they move Bitcoin from one another, or move cryptocurrencies from one person to another. So that's our reasons. Yeah. Of course. Yeah. I think that's true, but today people know about the popular mining tools of Monero, so yeah, it might be also a good reason. Thanks. Okay, a couple of methods to mitigate these attacks, how to stop them. The first method is to monitor the servers, monitor your servers. If you see your servers are running on a much higher CPU level than usual, then you might suspect this server is a victim to crypto mining malware. But monitoring your servers is not always so easy because usually servers are running many different processes, and it's hard to trace which one of the processes causes this high amount of CPU usage. It's not always the crypto mining malwares. So this is a method that can be used, but it's not extremely effective. Another method is secure coding, and that's something that everyone should do, right? The developers should always validate the input that they receive, the input of the data. But as any software developer knows, fixing one bug usually opens the door for 10 new bugs. So yeah, it should be done, but that's not a magical way to do it. Another method to do it is to patch the servers and patch the systems to the latest patch available. That's a good method. It's always recommended to use the latest patch, but the problem with it is that usually patching the system, especially in production environments, might take a lot of time. And that is because usually in order to reduce downtime, the developers first patch their environment in staging mode. They do the testing, see that nothing crashes, and only after that they deploy it into the production environment. An alternative to patching is virtual patching, where there is no changes to the system itself, and this can be done using some kind of outsource. Yeah, for example, using WAF. So some kind of outsource, not necessarily, but some kind of outsource security solution. Okay, a couple of yeah. Yeah, I think it's something inside secure coding or making your environment secure using the right configurations. Yeah, that's also a good way to do it. For example, if you have an open ready server, which is an open to the whole world, you should put the authentication on, because on default it's off. That's also a good method. But usually these kind of vulnerabilities happen when there is a vulnerability in the software itself, and the software itself, for example, if you develop a Drupal app, then there is a vulnerability in Drupal, and the Drupal will have the most high privileges. I mean, it's not possible to lower the privileges of the app you're using. So it might work, but if there's a vulnerability that is specific to the app you're using, then you need some kind of at least patch your system. Okay, a couple of key takeaways from this talk. First, you should know your assets and you should protect them. Your assets include your data, but also your computation power, your machines. And the next point is that RC vulnerabilities, they are a serious risk. We see more and more vulnerabilities released each year. The vulnerabilities has higher and higher risks. And these vulnerabilities, the RC vulnerabilities, are the entry point to your system. This is where the attackers, this is what the attackers are looking for. And if you block this entry point, then this might protect you. That's the best way, to block the entry point. Now, as we saw in our data, almost 90% of all the RC payloads, all the RC attack contained a payload that included a cryptomining malware. So probably this is the next thing, this is the next new trend that attackers are after. It's very easy for them to earn money. They don't need to sell anything to anybody. They just download the malware and don't do anything. They earn money. And that's why it's so popular in the previous last month, maybe even last year. And what are the attackers are after today? They're after your data, of course, but not only after your data, they are after your resources, after your machines and your computation power, and they can use it in order to just gain money, and that's what should be protected.